Good morning. So today we'll learn how to write the mechanism of the Wittig reaction. Okay, so the Wittig reaction. So there is something we need to know is that we need a reagent which is called the Wittig reagent or the phosphorus elide. Okay, so it is pH phenyl group, P bond, and C here we can have maybe H, maybe R, it depends. Okay, so two groups. So this one is very important. So let's start to start writing the overall of the reaction. So starting from a ketone, well, using the phosphorus halide, we are going to form, like, we are going to take only this part of the molecule, the C with the P bond, but it depends on the, well, pH. Sorry, let me just write it to understand. Well, pH, Phi, like this. Sorry, here we have P and here a P bond. It depends on what we have here, R and R. Sorry. Depends on what we are here. We are going to, let me just write them in green to have exactly the same thing here. Okay, so what we have done, we just took this part without the oxygen and we added, which is in green. Okay, written in green. So let me choose a molecule, for example, well, we need to start like from this molecule. Okay, so I'm just gonna write R and R1. Okay, so we need to make a Wittig reaction. So we need, sorry, R X. We need this molecule. Okay, and then what is going to be our product? So we can know from now our product is going to be, well, CO, we delete the oxygen and we add a hydrogen here and an R, okay? Because here we do have H and R, okay? And, well, let me write R2. Okay, R2 to make it different from the R that we have here, okay? So, and here we can keep R and R1. So this is our final product. Let me try to write the mechanism, okay? So the first thing we need to do is to, so the first step is we need to form our Wittig reagent, okay? Wittig reagent. So it is, we are going to start from this molecule, like a halide here. We can add a chloride, okay, a chlor, sorry. Just try to write it, okay? And we can react it with the phosphorus, okay? Sorry. Oops, not like this. Sorry, I lost my pencil. Okay, so P, and like this. Okay, so this is our molecule. So we're going to attack this carbon, okay, the most electropositive. We're going to attack it, and the chlor is going to be it's going to leave the molecule. It's a good leaving group, okay? So we are going to form R, and this carbon in red is here. So we're going to use this lone pair to complete the drawing the rest of the molecule. Okay, so here we have PH, phenyl group. Okay, so as you can see, we have two hydrogens here. Okay, so from the beginning we had the two hydrogens, and right now this had three and two lone and one lone pair, so it was neutral. But this phosphorus here now it has four bonds. Okay, it is attached to four atoms. So we are going to add a formal positive charge here on it. Okay, so remember that we are going to use a base, for example, this one. And all the time, remember that it gives you BUHY because it acts as a base, so it's going to grab the hydrogen, and then we add a negative charge on the carbon. Okay, so we are going to form this molecule. Okay, so this molecule it has a negative charge. Okay, here. Okay, so we don't forget that we still have one hydrogen. Okay, let me just write it here. One hydrogen and the negative charge. Okay, so this it could be written this way, or the negative charge it could be added here. Okay, I don't have to forget the positive charge here, so I can add the p bond here next to the phosphorus, and we have our reagent. Okay, so it's either this one or this one. Okay, both of them are correct. So these two are called phosphorus elide, okay, or the Wittig reagent. So one of these we are going to use it or to react it with, sorry, let me just write it here. We're going to react it with the ketone, okay? So using a ketone, let me write R1, R2, okay? So, well, in my case, I can use this form. I prefer this form, okay? So we can write both of them here. Let me just write, well, the first form was R, and here we had, sorry, an H with a negative charge here, and we had P like this. We also had a ketone, okay? So a ketone like this, R1 and R2. So what are we going to do right now? We are going to start from the oxygen, okay? Well, either from the oxygen or I would say from the negative charge, okay? So we are going to attack, it will act as a nucleophile, okay? We're going to attack this carbon, and this carbon is going to form an alkoxide, so which is going to attack this P, okay? So we write everything we had before, R1, R2, and we added this bond, okay? This bond, this red bond, like this. This one. And we had this one, H and R, okay? So, and we are going to draw P, but right now it has no, no positive charge on it, okay? So pH, and pH 1, 2, 3, 4, and 5, okay? So it's okay. A neutral molecule. So we are going to make like this. I'm sorry. If you don't remember how to do it, remember that you are going to form a P bond, okay? So, and the oxygen is going to leave. So this is what I'm going to do. Sorry, I'm going to add this here, this bond, so that I form a P bond, okay? And this one is going to be added like this, okay? So we are going to form, I'm going to start from this one. So this one is this one, okay? I have R and H. And here I do have R2, R1, okay? So cool. Plus, the other molecule is an oxygen here, P and 3P phenyl group. 1, 2, 3, 4, and 5. Okay, so this one is the product, the main product. Okay, so we formed an alkene. Okay, so using the Wittig reaction, like we form an alkene. Okay,